Okay, we've got this setup. We've got a slope, 30 degrees. We've got a 1 kilogram block on that slope, and a static coefficient of friction of 0.3. Is that block going to begin to slide down the slope?
What's the normal force?
I don't know. We can figure that out though. Remember, the normal force is the force that's perpendicular to the area. So which way is the normal force going? You're pointing that way?
Well, I guess it's coming down.
Is it this way?
It's perpendicular to the top of the box.
That?
Yeah.
You get that right. That's the normal force. It's normal, perpendicular. Normal is the same thing as perpendicular. So it's the perpendicular force, perpendicular to the surface. What's this force here? What did I just draw? Gravity's acceleration. The force of gravity, the weight. Yeah, weight's a better. Weight. Is there some relationship between the weight and the normal force? Let's take this. It's a horizontal. In this case, the weight is equal to the normal force. Everybody buys that? That's why if you're standing on the scale ought to be on the flat ground. Vertical wall. The weight is this. What's the normal force? 0, right? There is no normal force. So based on the geometry, we can figure out what that is. It turns out if you go through all the geometry on these, this angle here is equal to this angle here. 30 degrees. So really what we've got is the force of gravity is this weight. So what's our weight? Our weight is 1 kilogram times 9.8 meters per second squared. That's 9.8 newtons. I just use that little n just for now. Normally newtons are big n's, but I've got a normal force, so little. So really what we want to do is break this 9.8 newtons up into the normal force, which are used to, remember our force of friction is mu times n. Use that normal force. What's the other portion of that force? We're breaking the weight into two parts. The normal force, which way is the other vector of that weight going? Brandon's going like this, and that would be correct. It's going down the slope. So, just like before, so this is our 90 degrees here. So this is the force down slope, if you like. So I want to write an equation here between